Okay, now this question shows a leg that has been supported by this cloth here. There's a force here that's actually holding your leg up, and the weight of the leg itself, the weight of course will be acting down, and it is 150. So 150 is the force that's pulling the leg down, and this is the one that's holding the leg up, and then it balances. So the question asks for this force. Now at one look the question is actually very confusing because there are so many distances, but first of all let's find out where the pivot is. So in this case the pivot is actually at the hip area, because if the leg goes up and down, it is actually through the hip. So the hip is actually where the pivot is. So once you get this part right, you'll be much easier. So I'm going to simplify the drawing to something like this. Okay, so some of the other distances are not used. So this is the hip. The leg's weight is pulling it down, so that's 150 newtons. And then there is a force that's holding it up, so that is F. I do not know. The distance I've converted to meters, 0.5, and this is 0.5 plus 0.15, right? So the total distance here, so it's 0.65. So now this complicated drawing has been simplified to something like this. All the rest are no longer used. In fact, I would know that I don't need 35, I don't need 15. Why? Because they are parallel to the forces. I'm only interested about distance that are perpendicular to my force. So I actually don't need this, I don't need this. Okay, I don't bother about this because this part actually is connected to this force. So I only look at this part is not needed. So now with a much clearer picture, I can then do it like a simple balancing question. So the clockwise moment, which is this, is 75, right? 150 times 0.5. Anti-clockwise moment is F times 0.65. F is here, 0.65. Since they are equal, I will be able to work out my F, giving my answer to 3 significant figures.